actually go over a couple of things, referencing the questions about formulas and that kind of thing. I want to show you some of the things that you have in your head are actually on this formula chart. They look a little cryptic, so I want to reference that. But first thing is, I got this question some today, and I wanted to just really solidify this. I have questions on how do you tell the difference between Z versus t-test and when you do which. So, here it is. For sure, if you have a proportion problem, then you always use the Z-scores, okay? You always reference a Z-score. And that means that it is the actual real standard normal model. So then when you do computations, you're going to be doing norm CDF from Z to Z. There's no degrees of freedom for the normal model because it is just the normal model. And then inverse norm, if you're finding a critical value, your Z star, okay, of one tail, no degrees of freedom. That's kind of when you're finding that critical value. Okay. All right. But for means, you have an option. For means, there's two things that could happen, and we've already referenced this. If you have the standard deviation of the population, which rarely happens, I have not shown you this, I have not had you do this, and I will tell you that it's not going to be on the test tomorrow just because I'm not throwing that little, that little thing in there yet, okay? So, but when that does, then you get to do those problems just like the proportion ones, where you do a Z-score. It is completely normal, not nearly normal, and you do your inverse norm and your norm CDF and all that kind of stuff. But what we have had for means this chapter is when we have only been given the standard deviation of the sample. So that is when we use these t-distributions because they are more varied. Okay, we're using our t-distributions, which are more varied than the standard normal curve. That's why we call them nearly normal. So when we are doing computation, we're doing our t-CDF from the lower t to the higher t, because these are from least to greatest. And again, what's this degrees of freedom important for? Notating which curve, which t-curve to compute off of. Okay. And then, of course, to get a critical value, you're doing inverse t of one tail common degrees of freedom. Okay. All right, so with all of that being said, now let me show you the formulas and for interval and your Z-scores or your T-scores, where they're located on your formula chart. So I want you to envision the little yellow